the Coriolis Effect. You've probably heard of it. It's that invisible hand that's supposed to shape everything from hurricanes to the jet stream. We're all taught it's a fundamental force in meteorology. But what if it isn't? The source material we're digging into today asks a pretty radical question. I mean, really think about that. What if the explanation we've all accepted is not just a little bit off, but completely fundamentally wrong? Now, that is a massive claim, and it goes right up against a cornerstone of climate science. So let's dive in and really unpack these arguments. Okay, so before we can get into the challenges, we first have to make sure we're all on the same page about the textbook understanding of the Coriolis effect. Now, mainstream science is really clear about one thing. The Coriolis effect is not a real force. It doesn't actually push or pull anything. It's what's called a pseudo-force, basically an illusion that's created simply because we're watching things from the surface of a spinning planet. The classic way to explain this is the merry-go-round. Imagine you're on one, and it's spinning. If you throw a ball straight to your friend across from you, it looks to you like the ball curves way off course. But here's the trick. Someone watching from a bench nearby would see the ball fly in a perfectly straight line. It's your rotating point of view that creates the illusion of a curve. And according to the textbooks, this so-called apparent force is a huge deal. It's given credit for steering our entire jet stream, and most importantly, for giving those massive hurricanes their terrifying counterclockwise spin in the northern hemisphere. It is, for all intents and purposes, the bedrock explanation for how our large-scale weather systems work. But here's where things start to get interesting. According to the critique we're examining, the problems begin with that very same merry-go-round demonstration we all learn in school. A critique aimed at a TV news segment claims that their demonstration of the merry-go-round experiment is just completely wrong. The argument is that by having people throw the ball from the edge of the spinning platform, they're not actually showing the Coriolis effect at all. They're actually showing something totally different, centrifugal force. And this comparison really gets to the heart of that first critique. The argument is that to truly show the Coriolis effect, the person throwing the ball has to be at the center, at the pole, and throw it outwards. See, when you throw it from the edge, the ball is already being flung outwards by centrifugal force. So you're basically just throwing a curveball. This is the first crack in the foundation. But a flawed demonstration is one thing. The critiques go much, much deeper than that. They strike right at the core logic of using an apparent force to explain something very, very real. And this, right here, is the central question. Everyone agrees a hurricane has an unbelievable amount of real physical energy. But the Coriolis effect, by definition, is a pseudo-force. So how can something that isn't real, something that has no energy of its own, be the cause of one of the most powerful and energetic events on our planet? Physicist Miles Mathis puts it about as bluntly as you can. If the force is just an illusion, then the acceleration it causes must also be an illusion. But a hurricane's energy is devastatingly real. The point here, according to the critique, is simple. You just can't get real energy out of a fake force. It feels like a logical dead end. But the energy problem is just the start. The next major challenge is, honestly, even more surprising. It claims that the direction a hurricane spins is the exact opposite of what the Coriolis effect should produce. So, let's go back to that merry-go-round again. The ball always curves to the right of where you threw it. The critique argues that on the scale of the Earth, that deflection is always towards the south and west in the northern hemisphere. But think about a hurricane. It spins counterclockwise. That means its winds have to curve north and east to complete that circle. Mathis's conclusion is just stark. He says, the hurricane is backward. So you have to be asking, how does mainstream meteorology deal with these apparent contradictions? Well, the answer is in some very complex mathematical models, and a key ingredient is something called the Rossby number. But according to this critique, the equation for the Rossby number is where the science really goes off the rails. Yeah, this is a pretty heavy accusation. The source claims that the math in the Rossby number formula completely breaks down at the equator, that it's the mathematical equivalent of dividing by zero. And the argument isn't that this is just some small error. It's a fundamental flaw, a mathematical sleight of hand that they claim allows models to wrongly turn the apparent curve of the Coriolis effect into the actual energy-filled spin of a storm. And this math problem leads to the final big issue, what's called the inertial circle. See, for the weather models to work, they need these small, tight circles of motion. But the critique argues the Coriolis effect doesn't make little circles. It makes one giant open curve from the pole down toward the equator. And since that motion can never turn back north or east, it can't ever complete the tight vortex we see in a storm. It can make a hook, but it can never make a full circle.
So, if the Coriolis effect can't explain the energy or the direction or even the shape of a hurricane, then what can? Well, the source material we're looking at proposes a pretty radical alternative.
The alternative theory from Mathis gets rid of the pseudo-force entirely and replaces it with what he says is a very real one, a charge field. The basic idea is that space isn't empty. It's filled with this field of tiny spinning particles. And it's this fundamental underlying spin that imparts real energy and rotation to everything in it, from planets to storms. Now, without diving too deep into the physics, this alternative theory claims to solve all the problems we just laid out. It provides a source of real energy because it's a real force. It claims storms spin counterclockwise because that's the foundational spin of the field itself. And unlike Coriolis, which really only applies to huge systems, this proposed field is said to work at all scales, explaining everything from massive cyclones all the way down to the tiny vortex in your bathtub drain.
So, we're left with two completely different explanations for the exact same thing, the weather that literally shapes our entire world.
And this chart really lays out the core conflict. On one side, you have the established science, an apparent force that needs complex models to make it work. On the other side, you have a radical critique that calls the whole thing illogical, mathematically broken, and proposes a real, energetic force to take its place. Look, we're not here to tell you which one is right, but exploring this fascinating critique of the Coriolis effect leaves us with a much bigger question. When a theory this foundational is challenged, not just on a few details, but on its fundamental logic and its math, what does it actually take to change our minds? And how willing are we to re-examine the explanations we thought we already knew?